We're going to start by writing a polynomial in factored form. So yeah, yay, we're going to start with factoring. I know you're excited. When I look at these two problems here, I'm going to look at the first one, obviously, first. I notice that all three terms have an x in them that I can factor out. Because I don't know really how to factor an x cubed like we have been practicing with factoring quadratics or an x squared. So I'm going to factor an x out first, and when I take an x out of each of these terms, I'm left with x squared instead of x cubed minus 2x minus 15. Okay, no x in that last one. So I've taken the x out. Now if I were to distribute this back through, the x out in the front, if I were to distribute it back through, I would end up right back here with this equation, x cubed, 2x squared minus 15x, etc. But now I have something inside the parentheses that is much easier for me to factor. I must keep this x out front, but now I can factor this into two separate parentheses. So if I were to if I were needing to solve this, I could find my values of x. And just wanting to keep in mind, eventually we will be solving for the zeros of the function. And when you have a leading exponent of 3, you're going to have 3 solutions. If you have a leading exponent of 4, you're going to have 4 solutions. If you have a leading exponent of 5, you're going to have 5 solutions. They may be real. They may be some real, some imaginary. So just keep that in mind. You're going to have, the number of solutions depends on the leading degree of your polynomial. So in this case, we'd be looking at 3 different solutions, which is why you can see we're going to have 3 different things, 1, 2, 3, that are going to multiply together. And if we were to set this equal to 0, then we could solve it. We're not actually going to do that yet. So let's go back to my factoring. I want to look at this right here, factors of 15. So 2 numbers that multiply together to 15, but have a difference of -2. So I'm going to come over here and I'm going to look for those 2 numbers that multiply together to 15, but yet subtract to give me a -2. Oh, sorry, I guess I really technically need a -15, so keep that in mind. That's really a -15. Okay, so I notice that 5 and 3 multiply together to give me 15. I'm not going to make one of those negative yet till I decide which one is negative. One of them will have to be negative. I need a -2 to be my difference, so my 5 needs to be negative and my 3 needs to be positive because 3 minus 5 is a -2. So my 5 is negative, my 3 is positive. I multiply those to get my -15, and I can subtract those to get the -2. Well, that gives me what needs to be inside the parentheses. I need to have, since my a is 1, I need to have an x plus 3 and an x minus 5. So, done factoring. And from that point, you could solve if we needed to. Let's go ahead and factor this next one. Again, the 3 terms all have an x in them that we could factor out first, which would then leave us a quadratic inside our parentheses. So this time we're looking for factors of 12 that have a difference of -1. So we're looking for 2 numbers that multiply together to get -12. So factors of -12 that have a difference of -1. So I know 3 times 4 is 12, and I know that 3 minus 4 gives me -1. So that means my 4 is negative, my 3 is positive. So I'm going to break this into x plus 3 times x minus 4. So there's the factoring of that. If you have questions, please ask, write them down, whatever you need on that part. So that's example 1. Let's go ahead and look at example 2. Right here, example 2. Now we're going to find the zeros. Guess what though? They've already factored them for you. I want you to look at this. Just look at these, that we have 3 different factors. They're already done for you. Since there are going to be 3 solutions, what type of function do we have? I'm just going to let you know, since there's 3 solutions, I know it's a cubic function. It has a leading degree of x cubed. Okay, because I know there are 3 zeros. So I have an x cubed at the beginning. Same thing with problem B. But finding the zeros, it's already factored for you. So I'm going to set this equation equal to 0. That's important because once you set it equal to 0, then you can use that zero product property. I know that one of these three parentheses has to equal 0 for me to get a 0 when I multiply them all together. So in other words, that means x plus 2 must equal 0, or x minus 1 must equal 0, or x minus 3 has to equal 0. So, and you guys have done this and you kind of know that basically what's going to happen here is we're going to subtract 2 from both sides, and in this case we're going to get x equals negative 2. In this one we're going to add 1 to both sides and get x equals positive 1, and on this one we're going to add 3 to both sides and get x equal to positive 3. Okay, so just so you can kind of see, since our coefficient of all of our x's is an understood 1, notice that each of these, basically the solution is the opposite of what you see in the parentheses. That's what happens here. So my three solutions would be negative 2, 1, and 3. So that would be the zeros of the function. In other words, those three numbers are where my graph would cross the x-axis. Those would be my three x-intercepts. So again, let's look at this one. Set this equal to 0. I'm doing this just to show you why I can solve this. And looking at these again, all of my coefficients of x are 1. So I know that basically x is going to equal, since this is a positive 1 right here, x is going to equal negative 1, x is going to equal positive 4, and x is going to equal positive 5. And I really don't need the plus in there. I was just saying since I said positive, I wrote it. So positive 4 and positive 5. There are my three solutions. Again, if I were to graph this equation, these 3 points, negative 1, 4, and 5, are where my graph is going to cross the x-axis. Okay? All right, example 3. Again, if you have questions, write them down, bring them to class, or ask them in class. So example 3, graphing the function. Now we're going to go ahead and take it a step further and actually graph the function. So your first step is when you're given a function, whether it's factored or not, find the zeros. So we're going to go ahead and use example A from above, which we already decided our zeros were negative 2, 1, and 3. So I know my graph is going to cross the x-axis at negative 2, 1, and 3. So since our zeros are negative 2, 1, and 3, we're going to make a table and we're going to use values in between our zeros to find some other points. So I know that basically negative 2, when x is negative 2, y is 0. Okay, because these are my zeros. These are my zeros. That's the key here. These are 2 points, or this is 2 coordinates of a point, negative 2, 0. So I'm going to find negative 1. I'm going to find the y value for 0. I know 1 is the y value is 0 because, again, a 0 of my function. And I'm going to go ahead and solve for 2. And then I'm not going to put 3 on there because I don't have room, but I also know 3 is a 0. So I could go ahead and graph my zeros if I wanted to. Negative 2, 0, 1, 0, and 3, 0. So I know my graph is going to go through those points. So let's go ahead and find out when x is 1, when x is negative 1. Well, this is a little bit tricky because we don't have it. We could go ahead and FOIL these and multiply them together and we could get it into x cubed, or we could honestly just put negative 1 in for each parenthesis. So I could do negative 1 plus 2. That was like an H, sorry. Negative 1 minus 1, and negative 1 minus 3. So I can just put that x value, I could substitute it in for x, literally solve each parenthesis, and then multiply those 3 numbers together. So negative 1 plus 2 is 1. So there's my first number. Negative 1 and negative 1 is negative 2, and negative 1 and negative 3 is negative 4. So now I multiply those 3 numbers together, and negative 2 times negative 4 is positive 8. So there's 1 point. If I put 0 in for each of those x values, now let me go ahead and substitute a 0 in for each x value, just to show you what I'm doing. I'm going to do the work. So 0 plus 2, 0 minus 1, and 0 minus 3. I obviously end up with 2 times negative 1 times negative 3. Okay? So 2 times negative 1 is negative 2, and negative 2 times negative 3 is positive 6. Okay, now I'm going to put 2 in for my x values. And I'm going to do 2 plus 2, 2 minus 1, and 2 minus 3. So here I get 4, 2 minus 1 is 1, 2 minus 3 is negative 1. So that becomes a negative 4. Okay, so there are my points. So let's go ahead and graph those points. Negative 1, 8. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 0, 6, 1, 2, 3, 4, 5, 6. And 2, negative 4. 1, 2, 3, 4. Okay, so kind of looking at our end behavior. How do we determine our end behavior? Well, it's hard to on this one because we don't have it solved for us. We know it's x cubed. But if you guys kind of just look at your x, if we were to multiply all those through, since there are no coefficients of x besides a positive 1, if I were to FOIL all those and do all the multiplication, based on what I'm looking at, the x times the x times the x, my leading term is going to be x cubed. So I have an odd degree and a positive a. And with an odd degree and a positive a, it's going to be, my end behavior is going to be down and up. Okay? So in other words, I'm going to start down here, and my graph is going to look kind of like this. Making sure I get the turning points. Okay? So you can kind of see where I have turning points. I have 2 turning points, one right there. I have one right there. Okay, so it says use the zeros, additional points, and end behavior to identify and sketch the graph, and now we have done that.